Hello, everybody. Here we are, 7.2 general form. And general form is another form of an equation for a linear relation. Here's the equation right here, but I'll write it out for you again. It looks like ax plus by plus c equals 0. And we know another form for a linear relation already. We know y equals mx plus b. That's what we've been looking at so far in 7.1. Remember, m is our slope, b is our y-intercept. And I like this form a lot because it's very practical. And general form is, certainly mathematical, but less practical. We don't necessarily, by looking at it, know what our slope is or the y-intercept. But there are some conditions that we need to satisfy, and I'll type this up so you don't have to read my writing. 3 conditions to satisfy for this to be in general form. So number 1, A, B, and C must be integers. So an integer, as you may recall, is a positive or negative, let's say whole number or counting number. So that's, no fractions, no decimals. I think I missed a C there, no decimals. So there's condition number 1. So this A here, this B here, the two coefficients with our variables, and this C, the constant, all need to be positive or negative counting numbers. So like, 1, 2, 3, 4, 5, I can count those whole numbers, or -1, -4, -15, whatever. So that's the first condition. Our next condition, I'll type it down here. Is this better than my writing? Who knows? Condition number 2, let's see, all terms must be on one side, equaling 0. I think that's kind of maybe self-explanatory enough. So here we have our ax, our by, and our c all on one side of the equation. They all equal 0. And the last one, a must be positive. So the coefficient with the x. So we want to see this A right here, this first one, make that positive. So if, we already have a positive, we would move all of our terms to that side. We don't want a kind of like -3x. We got to make sure that's the positive one. We can have a negative y, that's fine, or negative coefficient on the y, but the x needs to be positive. So let's look at a few. We have a few equations here in slope-intercept form, and we want to convert them to general form. So at the moment, what have we got? We are not satisfying all the conditions currently. We have a negative x. We don't want that. We don't have all the terms on the same side. So let's start there. Let's move our x over to the other side. So I'm going to plus 3x to each side. So now we've got 3x, plus y equals 5. And now, so we have a positive y, but we don't have all of our terms on the same side. So let's move the 5 over as well. We got 3x plus y subtract 5 equals 0. And now we've satisfied all of our conditions. We have integers for the coefficients and for the constant, so we're in general form. Let's do the next one. We don't have all of our terms on one side. We do have a positive x, but we don't have an integer for the coefficient. We have a fraction. So let's deal with the fraction first. We want it's currently being divided by 3. To get rid of it, we're going to need to do the inverse operation. So we're going to need to multiply this whole side by 3. And what we do to one side of our equation, we're going to need to do to the other. So we're going to need to multiply this y by 3 as well. And so we'll get 3y now. 3 times y is 3y equals 3. We need to do our distributive property. So we need to multiply this 3 by the 2/3. We need to multiply the 3 by the -4. And -3 times 2/3, recall, 2/3 times 3 is like 3 over 1. You would get 6 over 3 or 2. So that just kind of cancels out those 3's. You could have cross-reduced if you want. So we'd be left with a 2x. And then -4 times 3 leaves us with a -12. Okay, so now we've satisfied our first condition. We don't have integers, or we do have integers now. And we got a positive x, beautiful, but we need all of our terms on one side. So over here we have a positive 3y. Let's subtract 3y from each side to move that term over. And we're left with 0 equals 2x subtract 3y subtract 12. You can have the 0 kind of on either side. I know up here it says ax plus by plus c equals 0. It's okay if you have 0 equals ax plus by plus c. And this last one I changed. Maybe if we have time at the end, I'll show you the decimal version. I think I wanted us to try a fraction with different denominators first, just to get us into the idea of having a kind of lowest common factor. And so we want to find what is the smallest number that both 2 and 3 go into. So the lowest common multiple actually is what I'm looking for. The first number that both 2 and 3 go into is 6. So I'm going to times both sides by 6. Okay, so we're going to end up with 6y equals, -3 over 2. Let me show you what that's going to look like times our 6. So we got -3 over 2 times 6 over 1. Let's multiply the tops. We're going to have -18 over 2, which equals -9. So now we have -9x. And if we had this 1/3 times 6, if we multiplied the tops and multiplied the bottoms, we'd have 6 over 3. And 6 divided by 3 is 2. So now we've satisfied the first condition. We have a, b, and c are integers. Our x is negative. So we do want to move our x over to the other side so that it'll be positive. So let's add 9x to each side. Now we've got 9x plus 6y equals 2. And our last one, we don't currently have all of our terms on the same side. We have this 2 on the other side. So I need to subtract 2 from each side. We'll have 9x plus 6y subtract 2 equals 0. And now we've satisfied all the conditions. Now we have integers for our coefficients and for our constant. We have a positive x, and we have all of our terms on the same side. And as I said, I'll maybe show you this decimal one if I get time at the end. There's a couple of ways to conceive about it. We do want to get rid of the decimals as well. There's kind of a final step you might need to do. So I'll see if we have time to do that one. The next one, determine the intercepts of each line. And there's a few things we need to remember about the nature of intercepts. So let's think about our y-intercept is when x equals 0. Okay, this is our x right here. These are the 1s, 2, 3, 4, 5. These are the negatives 1s, -2. Right here is where x equals 0. So where it crosses the y is where x equals 0. And so what's true of our x-intercept is when y equals 0. So where it crosses this line right here, where it crosses this, is these are our positive x's right, or y's right here, and negative y's there. This is where y equals 0. So when we're looking for our intercepts, or a way of thinking about graphing this line, one way you can do it is to find the y-intercept and the x-intercept and connect those two dots. So we can do that by inputting 0 in and solving for the other one. So let's do the first one. Let's find our y-intercept. So that's when x equals 0. So we can input that. We can go 2 times 0, subtract y, plus 4 equals 0. And then we're going to solve for y. So that's now 0. And we have negative y plus 4 equals 0. Let's move we want to know what positive y is. We want to know what y itself is. So let's add y to each side. And we get that 4 equals y. So that means that when x is 0, y equals 1, 2, 3, 4. So we know that's a dot on that line right there. And let's do the next one. Maybe I'll use a different color. I'm going to have room maybe right here. Now we want to find our x-intercept, and that's when y equals 0. So we're going to go 2x, subtract 0, plus 4 equals 0. So we got 2x plus 4 equals 0. Let's move. I want to have a positive x, so let's subtract 4 from each side. Subtract 4, subtract 4. And we get 2x. Now I've moved to blue. Oh, well, equals a negative 4. And let's go back to green. We want this x by itself. I'm going to divide by 2. Divide by 2. And so x equals negative 2. That's negative 4 divided by 2. And so when y is 0, x equals negative 2. And so we know our line, at least, looks like that. Okay, so it's going to look something like that. And then you can, now we kind of know the slope of our line. We know there's a rise of 1, 2, 3, 4, and a run of 2. So you could go 1, 2, 3, 4, 1, 2. We know there's another dot right there. So you can kind of easily from there go the other way. But let's do our next one. They just asked us to determine the intercept. So let's do this one. And so now we're just going to input 0 again. So we're going to go 2 times 0 plus 3y subtract 9 equals 0. 2 times 0 is 0, so that's gone. We now have 3y subtract 9 equals 0. Let's add 9 to each side to get it onto the other side. Oops. Plus 9 plus 9. So now we got 3y equals 9. And to get the y by itself, let's divide by 3 on each side. And we have it that when x equals 0, y equals 3. So when x equals 0, y equals 3. Maybe let's do a different color. Right there. And our other one, now we need to solve. Hang on, I've got to let my cat out. Okay, sorry about that. Now we need to input our 0 in for our y. So we want to go 2x plus 3 times 0 subtract 9 equals 0. And now 3 times 0 is going to be 0. We have now 2x subtract 9 equals 0. Let's move our 9 to the other side. And we get 2x equals 9. And we're not going to have, I guess, as tidy a solution as we did last time. We're going to divide by 2, divide by 2. And what we're going to have is x equals 9 over 2, or 4.5. So we can still graph that. It won't be as beautiful, but we can still manage. So x, when y equals 0, x equals 1, 2, 3, 4.5 right there. And there's 2 dots on our line like that.